Hello everyone, this is Team Sparks, and our problem statement is developing an AI powered outfit generator using the generative models and the user search history to provide personalized fashion recommendations. So, as we know that in this era where generative AI is taking has captured almost most of the market in all the domains, we found that the problem or one of the enhancements that could be done to online shopping is using generative AI to design an outfit which takes into account the ongoing trends as well as the user's preference and designs it which would make it a personalized outfit for the user. This can be done while taking into account the user's individual preferences and the search history. The primary objective is to design and implement a generative AI system that can analyze and synthesize current fashion trends from various sources and combine them with insights gathered from users' past searches to create unique and appealing outfit recommendations. The solution that we came up with is developing a modular architecture that integrates data aggregation, trend embedding, user preference modeling, and generative techniques. This will use the combination of supervised, unsupervised, and reinforcement learnings of machine learning paradigms and advanced optimizations like gradient clipping, learning rate scheduling, and model ensembling. The system performance will be rigorously evaluated using both quantitative and qualitative metrics. The different technical aspects are real time data aggregation analysis, user preference encoding, data preprocessing and augmentation, privacy and data security, generative model architecture, and fashion trend embedding and style fusion. Talking about the real time data aggregation and analysis, what we have what is done in this part of the aspect is that web scraping and apis are used. Web scraping libraries like Beautiful Soap or Scrapy can be employed to extract data from fashion websites. APIs from social media platforms like Instagram and Twitter and also Pinterest can provide access to visual trends. Then we also perform the cleaning, like we remove the duplicate entries, irrelevant information, and missing values. Text data can be pre-processed through techniques like lowercasing, stop word removal, and stemming. The topic modeling will happen after that, which is to identify fashion trends from text data and using latent Dirichlet allocation. These models discover underlying topics within a collection of documents and extract relevant keywords. Then we employ image analysis using computer vision and CNN pre-trained on fashion datasets can identify clothing items, color, pattern, and styles from fashion images. Fashion trend embedding and style fusion is mainly about fashion related keywords and phrases which can be converted into vector representations using pre-trained word embeddings like word to vec or globe. These embeddings capture semantic relationships between words. Then we transform based on the embeddings. Utilizing transformer models like BERT, the system can understand the context of fashion trends from textual descriptions, allowing for more nuanced embedding. Then we go for style fusion, which is combining fashion trend embedding and user preference encoding, which involves mathematical manipulating their respective latent spaces. Techniques like vector addition or concatenation can blend these styles. To ensure user preference influence the generated outfits, conditional generation can be employed. This is how the whole thing would work. Then we have user preference encoding. User search history and interactions can be encoded using RNN or transformer based models like LSTM or transformer. These models capture the sequential nature of user behavior. Attention mechanism within transformers enable the model to focus on specific part of the user history that are most relevant for generating personalized recommendations. In a GAN, the generator creates outfits and the discriminator evaluates their authenticity. These networks compete against each other, leading to the generator improving over time. Encoder and decoders like VAE encoder user preference and trends into a latent space, and the decoder generates outfits from this space. The model learns to generate diverse and realistic outfits while considering user preferences. The loss function for the generative model will comprise multiple components: a fashion trend adherence loss, a user preference alignment loss, and an adversarial loss. These components will be balanced to achieve desired outcomes. Generator creates outfits and a discriminator evaluates their authenticity. This takes place in the generative model architecture. These networks compete against each other, leading to the generator improving over time. Data preprocessing and augmentation. The raw images will be resized to a consistent format, normalized to a common color space, and potentially cropped or padded to a standard aspect ratio. Data augmentation for text can involve synonym replacement, word dropping, or random insertion to create variation in user input. Noise is added to user data before any analysis to protect individual privacy. This noise ensures that individual contributions cannot be reverse engineered from the aggregated data. User data remains on individual devices. Model updates are sent to a central server, aggregated and used to improve the global model. The central server never directly accesses user data. So this is how we plan to implement this uh, generative AI outfit generator. And this is our team. Myself, Simran Patnaik, with two of my teammates, Aditya Sandilya and Padmakshi Mandal. Thank you.